Hello and welcome to Kafka tutorial at Learning Journal. We have learned almost every concept associated with Kafka producers and consumers. We learned Java APIs for Kafka and created several examples to put them to use. In this session, we will cover a suitable method to handle schema evolution in Apache Kafka. So, schema evolution is all about dealing with changes in your message record over time. Let's assume that you are collecting click stream and your original schema for each click is something like this. Okay, so you have producers that are sending this data to Kafka, and you have consumers that are reading this data from Kafka and doing some analysis. We have already seen this kind of example in one of my earlier videos. If you missed that, go back and watch custom serializers and deserializer. I am sure you can deliver a solution to this requirement by implementing a custom serializer and a deserializer. Okay, so you had this system in place for few months, and later you decided to upgrade your schema to something like this. The problem starts here. If you are changing your schema, you need to create new producers because you want to send some new fields, right? But I have two more questions. Do I need to change all of my current producers? I mean, I am fine to create new producers to include additional fields, but I don't want the system to break if I am not upgrading all of them. Do I need to change my existing consumers? Again, I am happy to create some new consumers to work with newly added fields, but my current consumers are doing good and they have nothing to do with the new attributes. I don't want to change them. So, I don't want to change my current producers and consumers because that will be too much of work. So what do I want? In fact, I want to support both old and new schemas simultaneously. So can I support both versions of a schema? In a standard case, if you change your schema, you have to change everything: your producers, consumers, serializer and deserializer. The problem doesn't end there. After making these changes, you can't read old messages because you change the code, and any attempt to read old messages using new code will raise an exception. In summary, I need to have a combination of old and new producers as well as a mix of old and new consumers. Kafka should be able to store both types of messages on the same topic. Consumers should be able to read both types of messages without any error. That's what is a typical schema evolution problem. How do you handle this schema evolution problem in Apache Kafka? But do you know how do we take care of it in other systems? The industry solution to handling schema evolution is to include schema information with the data. So when someone is writing data, they write schema and data both. And when someone wants to read that data, they first read schema and then read data based on the schema. If we follow this approach, we can keep changing schema as frequently as required without worrying to change our code because we are always reading schema before reading a message. There are pre-built and reusable serialization systems to help us and simplify the whole process of translating messages according to schema and embedding schema information in the message record. Avro is one of them. It is the most popular serialization system for Hadoop and its ecosystem. Kafka follows the same approach and uses Avro to handle schema evolution problem. Let me give you a brief introduction to Avro and then we will create an example to see how all of this works. But before that, you may need to download Avro tools because we will be using it in upcoming example. I have shared a direct link to the Avro tool in the description section. If the direct URL is not working for any reason, you can go to Avro release page and follow the download link from there. A link to the Avro release page is also available in the description. Okay, so we need to understand how Avro works. Then we will explore how to implement it in Kafka. So Avro is a data serialization system and it offers you 4 things. Allows you to define a schema for your data, generate codes for your schema, provide APIs to serialize your data according to the schema and embed schema information in the data. Provide APIs to extract schema information and deserialize your data based on the schema. That's it. That's all a serialization system can give you. So let's see how it works. We will follow the 4 steps listed here. So if you have some data and you want to serialize it, the first thing is to define a schema for your data. Avro schemas are defined using JSON. So let's define a schema for our clickstream record. So here is my schema file. The name of my schema is click record and there are 6 items. The first field name is session ID and the data type is string. Session ID and channel are mandatory. However, the browser, campaign and IP address can have a null value. The referrer has a default value none. It is simple schema. However, Avro supports many other complex data types. For more details, you can refer to Avro specification. I have added a link in the description. Okay, let's come back to the second step. Generate code for your schema. This step is simple. We will use Avro tool to generate code. Okay, so you can see that I have my Avro schema file and Avro tool in this directory. So I execute my Avro tool. Give it a command to compile schema. Then I give the schema file name and destination directory. Okay, hit enter and done. So you can see that I have a Java file now. That's my source code generated by Avro tool. Let's quickly look at it. Okay, lot of things. But seems like it is a class for my click record. With get and set methods for each field. Okay, let's come back to step 3 and 4. Avro provides API for serializing my data. So I can use click record class generated in step 2 to create my data objects, and then I can use Avro APIs as stated in step 3 to serialize them and send to a Kafka broker. That's what a Kafka producer and a serializer do. So basically I have to use a serializer that embeds schema information and uses Avro APIs to serialize my data. Similarly, on the receiving end, I can use Avro APIs as stated in step 4 to deserialize those messages back to click record object. That's what a deserializer does. So at the receiver end, I have to use a deserializer that extracts schema information from the message and uses Avro APIs to deserialize my data back to the click record object. The point I want to make is that everything ultimately goes to an Avro serializer and Avro deserializer. Producers and consumers will only use the generated class to create data objects. Serializer and deserializer take care of rest. So let me redefine these 4 steps regarding Kafka implementation. So the first step is to define an Avro schema for your message record. We have already done that. The second step is to generate a source code for your Avro schema. We have done that as well. The third step is to create a producer and use Kafka Avro serializer. And finally, create a consumer and use Kafka Avro deserializer. The whole process is quite straightforward. Kafka Avro Serializer and Kafka Avro Deserializer take all the complication away from a developer. You don't have to learn and use Avro APIs to serialize and deserialize your data. All that is already done and bundled into Kafka Avro Serializer module developed by the Confluent team. Impressive, isn't it? Now let's look at the code for a producer. The code looks familiar, right? We have a topic, Avro clicks, and we want to send our click records to this topic. Like every other producer, we create 3 mandatory properties and set appropriate values. Our message keys are going to be a string, so we configure the key serializer class as string serializer. Our message values are going to be according to Avro schema, so we set the value serializer class as Kafka Avro Serializer. The Confluent team developed this class and it takes care of all the serialization activity. It protects us from learning Avro APIs and takes care of all the complexities of serialization work. The next property is Schema Registry. This one is new. It's a new component developed by Confluent team. You might be wondering about the purpose of this tool. So far, we learned that Kafka Avro Serializer would take care of all the serialization work at producer end, and Kafka Avro Deserializer will take care of all the deserialization work at the consumer end. But how do they communicate with each other about the schema? The deserializer should know the schema. Without knowing the schema, it can't deserialize the raw bytes back to an object. That's where the schema registry is useful. The Kafka Avro Serializer will store the schema details into the schema registry and include an ID of the schema into the message record. When Kafka Avro Deserializer receives a message, it takes the schema ID from the message and gets schema details from the registry. Once we have the schema details and message bytes, it is simple to deserialize them, right? So that's where we use schema registry. Okay, let's come back to our producer code. After setting up all the properties, everything else is straightforward. We create a click record object, set values for the fields, and send it to Kafka broker. I hope you remember that we generated the source code for this click record class using Avro tool. Now we are using it in our producer. That's all we do in a producer. Now let's look at the consumer code. The consumer code is also familiar. We set up properties including schema registry URL and value deserializer as Kafka Avro Deserializer. We have another additional property, specific Avro reader as true. If we are using Avro schema and code generation for the schema, this property is mandatory. In fact, there is another generic method to use Avro schema without using Avro code generation tool. But I am not covering that part in this video. So if you are generating code for your Avro schema, set this property as true. After setting all the properties, we create a consumer instance, subscribe to the topic, and start polling and processing messages. Kafka Avro Deserializer takes care of all the pain of deserializing messages and converting it back to the click record object. So, we are ready to compile and execute the producer and consumer and see all of this working. But this example is dependent on Confluent platform. The schema registry and Kafka Avro Serializer module is part of the Confluent platform. To execute this example, we need to download and install an open source version of the Confluent platform. This session is getting too long, so I am splitting it into 2 parts. In this first part, we covered the notion of schema evolution and looked at Avro as a solution to the problem of schema evolution. We created a schema, generated code for the schema using Avro tool, then we learned how a producer and consumer would use Avro schema. We talked about schema registry and its purpose. In the next session, we will download and install Confluent platform. We will then compile and execute our code. But the whole point of using Avro is to see how to handle changes in the schema. So we will modify our schema and learn how can we support both old and new schema in a system where both old and new producers and consumers are alive. Thank you for watching Learning Journal. I am truly dependent on you to keep bringing new tutorials. So please subscribe and share it with your friends and colleagues. Keep learning and keep growing.